In this video, we're going to look at how you can solve trig equations that involve factorising. So this is quadratic factorising. So funnily enough, sometimes when you're doing these trig equations, you come across something that looks like this. And this one has sine squared in it. Now when we write sine squared, so sine squared theta, we do the sine, then the squared, then the theta. But that really means sine theta all squared, right? We just put it there to avoid any confusion with sine theta squared, where like theta is squared, not the whole thing is squared. Anyway, just something worth knowing. And funnily enough, with a lot of these, you can just treat them like a quadratic and then factorize them and then use the null factor law to set yourselves up with some trig equations you already know how to solve. So let's do this one just to get a feel for it. Now, what you can do is if you're feeling a bit uncomfortable with this kind of thing, you can just give yourself, make it a bit easier for yourself by just, if you've got one like this where you've just got the one trig function, if I say let x be sine theta, then, well, this is sine theta all squared, so that would be equivalent to 4x squared take 2. And now this is something I'm probably quite comfortable solving, right? So that is, if we think about it, well, that is 2x all squared, take away square root of 2 squared equals 0. So if I write it like this, I can see I've got a difference of 2 squares. So then this is the same as 2x take root 2 times by 2x plus square root 2. And from here, I might want to re-substitute. So this is saying either I've got 2 sine theta take root 2 is equal to 0 from our null factor law, or the other one, 2 sine theta plus root 2 is equal to 0. So if I rearrange this, I'm going to get what? Sine theta equals, so I add that over, I get root 2 over 2. Root 2 over 2. And here it's just going to be the same, but now I'm subtracting the root 2, so it'll be sine theta is equal to negative root 2 over 2. So now I have myself, funnily enough, two trig equations that I can solve relatively easily. I might remember my special triangle where I've got 1, 1, root 2, and what we're doing radians, so I'm going to call this pi on 4. And if I think about it, so sine is opposite over hypotenuse, so sine of pi on 4 is going to be 1 on root 2, and if I were to rationalize it, I get root 2 over 2. So I've got to find all the times that sine theta equals root 2 and 2, but funnily enough also when it equals negative root 2 and 2. So I mean we can do them separately. So I think about with the positive ones, it'll be CAST. So positive there and there, where both of these are pi on 4. So it's pi on 4 is one angle, the other one around there is 3 pi on 4. So theta equals pi on 4 or 3 pi on 4. Then for the negative one, well, that's going to be in the tan quadrant, the third one, and in the cos quadrant, the fourth one. Well, that's pi on 4, that's pi on 4. So in terms of the actual angles, well, we've got around here, what's that? So pi plus pi on 4, we got 5 pi on 4. And all the way around, except not quite. There's pi on 4 less than all the way around, so it's, what, 7 pi on 4? So to write our final answer, I might just write it in yellow up the top, because I'm kind of running out of space. You know, in terms of the answers that would solve this equation, it's all of these, isn't it? They're all going to work, because with our two null factor law, they're all going to solve this equation. So theta, let's just write it here. Theta equals what? Could be pi on 4, could be 3 pi on 4, could be 5 pi on 4, or it could be 7 pi on 4. And all of those angles would solve this equation in that domain. So yeah, we've done it.